I just want to start by saying thank you to Dr. Bradley for those kind, flattering remarks. Aaron and I are honored to be here today, and I don't know that we deserve all that you said, because the truth of the matter is, when we started this, we never dreamed we'd end up here 2 years later, and we certainly wouldn't have if it weren't for the work of great organizations like the American Principles Project, the Pioneer Institute, the Heartland Institute, and others. We wouldn't be here were it not for principled legislators, many of whom are here in this audience today, and we certainly wouldn't be here without the hard-working grassroots effort from activists all around the country who've taken up the call to fight and spread the truth on this issue. I come to you as a wife and as a mother of 4 children, one of whom I'm very proud to have here with me today. And I came here and I'm involved in this issue because of something that happened, well, about 2 years ago. It was the fall of 2011. And it was the result of my 3rd grader coming home with some new math papers. She's at a parochial Catholic school, and suddenly the papers that were coming home looked very different than the math papers we had seen in the past with our older children. 3 things jumped out immediately. One, there was a shockingly small amount of arithmetic on the papers that came home. Secondly, when there were problems to be done, students were to approach them in odd ways, unfamiliar to us as parents. And thirdly, there was an inordinate amount of time spent explaining your answers with very scripted responses. And when I talk about the scripted responses that they want for the explanations, I often refer to the bridge problem. Some of you have probably heard me tell this, but for those of you who haven't, my 3rd grader came home with a paper. The question was, writing to explain. Bridge A is 407 feet long. Bridge B is 448 feet long. Which bridge is longer? So my daughter wrote, Bridge B is longer. I found this out by just looking at the numbers and seeing that and just seeing that 448 is greater than 407. Now, as an adult, I thought that was a pretty good answer for a 3rd grader. In my mind, greater than is a mathematical term. But I was wrong. She got that answer mostly wrong. She got 1 point out of 3. The scripted answer they were looking for was, I compared the add-ins in the hundreds column and saw that 4 and 4 were equal. Then I compared the add-ins in the tens column and saw that 4 was greater than 0, and so on. That was the type of scripted response that they wanted her to give. So that's what we mean by a great deal of explaining your answers. So the parents at my school became very upset and very concerned. They went to the principal, who quickly decided he better call in the sales lady for the publishing company. So she came from Pearson Publishing Company, and we all got a nice sample of the product, and we were told how lucky we were because our students had one of the very first Common Core line textbooks in the country. Well, when it quickly became apparent that parents still weren't feeling so lucky and they weren't really buying what she was trying to sell them, in frustration, our principal said, look, I know parents don't like this type of math because none of us were taught math this way, but we have to teach it this way because this is how it's going to be on the new PARCC assessment. And that was the very first many of us had heard that Indiana was scheduled to have their state test replaced with a new federally funded test known as the PARCC. Suddenly we realized the decision-making, the ability to affect change had left the building. In fact, it had left the state. It now resided with unknown, unelected people far from home. So I'm here today to just show you, hopefully now we can look at the slides, a few examples of what this fuzzy math is that's gotten so many parents' attention and concern. This was the very first worksheet that caught my eye. So my 3rd grader came to me and she said, I can't remember what I'm supposed to do. And I looked at it and I started to try to explain the method that they were using. I could have obviously given her the answers to fill in the boxes, but I didn't think that was the right thing to do. So I started to try to explain, and I looked at it and I said, well, you're supposed to take the second number, 34, and you're supposed to say 30 plus something. Then you go back and you take the first number, 53. You say 53 plus something equals 83, and then you take that 83 and you add it to something else, and that makes 87. So that's how you add 53 and 34. I was at a complete loss as how to explain the method they were using. Now, over some time, I came to find that what they were doing, that they did throughout the year, is break the numbers apart and then put them back together in different ways, and then combined it all together. So, for example, with a 3-digit addition problem, let's say 312 plus 215. The child is to break it apart, and 312 is 300 plus 10 plus 2, and 215 is 200 plus 10 plus 5. And then they're told to add the 300 and the 200 first. That makes 500. And then add the tens, and then add the ones, and then go back and add the hundreds, tens, and ones. But the problem is that is the complete opposite of the standard algorithm. Rather than starting in the hundreds column, you're to start in the ones column, as you all know. So many children became confused when they were taught the standard algorithm eventually. They all wanted to start in the hundreds column, which was a problem. This is just one example. We have others. My next example is a real-life example that was sent to us, and it's very similar to what we're seeing come home. And it's a 4-point problem of 15 plus 17. Now, if the child does the math and gets the answer wrong, they get 1 point for trying. If they add 15 and 17, and use the standard algorithm and get the right answer, and they get 32, they get 2 points. However, that is not proficiency. To be proficient, I will show you what they need to do next. They need to be able to draw a picture to show that is deeper learning, that is a deeper understanding. And to get 4 points to show that they really have mastered the skill, they need to be able to explain it again in writing. I took 5 ones units from the 17 group and added them to the other 5 ones units, etc. So this is the type of deeper learning that we're seeing all across the country, frankly. And then I'll give yet one more example that appeared on the sample items from the Smarter Balance, one of the 2 testing consortiums. This is for 4th grade math. You can see the child is to do 26 times 32. Now, a child who has been taught the standard algorithm and does it the traditional way over in the corner and gets the right answer will not get full credit. If they look at that box and they become confused because that's not the method they were taught, and they don't fill in that box correctly and try to figure out exactly what's going on with how to use what I've been told is called the rectangular method, they will not get full credit, and they will be found not having mastered the skill. They would not get full points on this question. So this is just a little bit of a taste of what it is parents have become frustrated about, and when you hear about fuzzy math, these are the types of things that are coming home in backpacks all across the country. And I would say that the effect is threefold. I think it's first of all very clear that when Common Core proponents say Common Core is just telling the teachers what to teach, not how to teach, I think this exemplifies that is absolutely false. It is indeed telling them how to teach. It is indeed ushering in fuzzy math. And that's having, an effect on the children. Some are becoming confused by all the different strategies they're being told they have to learn. And it's at the expense of practice. So for many children, they are not getting enough of the practice necessary to become proficient, and it will likely haunt them later at higher level mathematics. And then for all students, it is really slowing down the pace of the progression of skills in mathematics. So when I hear that they won't be ready by 8th grade, I believe it absolutely. Because when you look at the pace of what I consider to be real mathematics in the lower grades, it is not moving at the pace it needs to reach algebra by 8th grade. And again, I often hear schools and people say, well, we go above and beyond. But to my knowledge, I've yet to see a school that has embraced Common Core where the 4th graders are using a 5th grade Common Core textbook. So I simply don't see how that is the case. But again, this fuzzy math is nothing new. It's simply a remade version of the new math that was in the 60s and 70s. It's here again all over. But what is new is that it's being inflicted upon the entire nation at one time. And getting rid of it is now no longer very easy. And I would also like to point out, I've had recently some Common Core proponents, when looking at the evidence presented by Dr. Milgram and Dr. Werman, they say, well, okay, well, but what's the harm? We needed to try something. And, you know, it may be easy for them to say, what's the harm? But to me, with a parent, you know, as the parent of children in school, and for all the other parents who happen to have children in school today, it's not so easy, because our children get only one shot at a good education. And when this fails, which it will, those who sit in positions of power and authority, who have the ability to stop it right now and choose not to, they'll be able to walk away. And some of them will walk away with their pockets lined. But our children can't walk away. They will be forever impacted by the education policy decisions being made by such people today. Let's hope and pray that they do the right thing.